Okay, let us learn 10.7. And let me tell you, if you're stressed about the test, that we're in good shape. Like, we'll do 10.7 today, 10.8 tomorrow. It probably will take us more than one day, but like at most we'll be done learning on Monday, and we can start reviewing that day. And so like I'll keep showing up for these morning sessions. I don't have a meeting next Wednesday, so we can come to that morning session too and review some more. And next week I'll start splitting my AB classes so that like AB people will work on this question and BC people you're better off working on this question, like a BC specific question. And that way you'll have like enough review. It's like 2 full weeks of review plus like 2 classes a day of review. So don't stress. You'll be all good. All right. Now, here, let me show you the last thing you learn, or like the thing that sets me up best to transition to today's stuff is this question, example 2, where we made a little power series for this function. In other words, we turned this function into a polynomial. But notice, here's a good way to say it. You don't have to edit your notes, but another way to write this would be like a series like this. So if I may just teach my class. What was it? 3 to the end. Oh, it's 20. Okay, that's another way to write this polynomial right here. And notice that this series has this variable in it. So if I asked you, does this converge or does it diverge, this series right here, this one that I'm circling, you would have to say, it depends. What is this x right here? Because if that's a really big number, then maybe it diverges. But if it's a really small number, or like x minus 2 is a really small number, then maybe it converges. And that's the point of today, is that you're going to get infinite series, and you're going to get asked, does this converge or diverge? And you're going to say, well, it converges for these x's, and it doesn't converge for these other x's. So basically, that first page of 10.7 that says a bunch of stuff, that's a summary of exactly what I just said. So all of this stuff, it's like review of what you already know. Power series, it's what I just said. This says that depending on the x value that you put into the series might converge or it might diverge. And then this box is the biggest important box that says, like, there's basically 3 options. Either you plug numbers into this x and it makes the series converge only sometimes. Wait, let me make sure I'm doing it in the right order. Okay, so then let me do it in the exact order that it's written here. It may be that I plug in a bunch of numbers into here and it never converges. This series never, like let's say I plug a 7 into here, it diverges. Plug an 8 into here, it diverges. 9, 10, all the numbers that I plug in diverge, except for maybe if I plug in c into here, then of course I'll get c minus c is 0, and then I'm adding a bunch of zeros. 0 plus 0 plus 0. So in that case, of course, that series would diverge, or would converge. So every series of this sort right here that I'm circling with my mouse, all of those have to converge at least at the center, like at 0. That's one possibility. Then there's another possibility that maybe I plug in, I don't know, any number between 5 and 7, and that makes this result small enough that the series converges. In which case, that's what this number 2 here says, is that there's some real number so that the series converges as long as you're within that number, and it diverges if you're outside of that number. Or the last thing that could happen is you can plug in any number for x, and this series still gets small enough that it converges, in which case that's called, well, it says here that the series converges for all real numbers. And then it talks about a radius of convergence. That's just basically how far can you get from C, where all the numbers between there can still converge. So that's what a radius of convergence is, and then you'll also get asked for an interval of convergence, which we'll talk about just as we do an example. I think that's better off. We're better off doing an example. Now, interval of convergence, that's what I was just talking about right here. And then the way you check, like, what numbers can I plug in, you obviously can't check one by one, because you can't plug in 0, then 0.000001, then 0.00, like, you can't plug in number by number. So what you do is you use the ratio test, and you'll see how as we do an example, but that's the summary. Series will converge absolutely, and diverge when that, okay. This just tells you that it's something that I'll tell you when we do an example. All right. And then example 1, I think I actually want to save for last. Because it's going to be hard to explain it before you gain an intuition for how these intervals and radii of convergence work. So remind me to come back to this one at the end of today. But I want to do these examples first. Hey, Bree. Okay. Now I'm conflicted because the way you do these, this one is the hardest computationally, but it gets maybe the results that might make the most sense. But I think, well, let's just do them in order. But get ready to, like, don't get scared because this one is super, super heavy computationally, and then these two are pretty easy. So this one will take us a long time. Don't feel like every single problem in the world will take you that long. But yeah, let's just do them in order. It's wondering, okay, what numbers for x can I plug into here so that this series at the end will converge? So just so you gain an intuition, don't even write this down, but if I was told that by my teacher, I would be like, what are you talking about, plug into here so that it converges? Like, watch this. If I plug in some specific number like 6, then the resulting series would be n equals 1 to infinity of -1 to the n plus 1 times 6 minus 5 is 1 to the n over n times 2 to the n. And then you plug in a number, and then you check, oh, does this converge or diverge? And I think it would converge, because this 1 to the n is just 1. That's why I'm trying to cover it up. It doesn't even matter, so that would converge. So that's an example of, like, 6 is a number that I can plug in, and this still converges. See what I'm doing? Now you got to do that in general for every x in the world. And the way you do that, again, is with the ratio test, which, if you forgot, says take the limit as n goes to infinity. This you should write down. Limit as n goes to infinity of the absolute value of the next term over the current term. And we have to be, like, conservative with our space. In fact, I might make more space for myself so I can write big. Okay, next term over current term, so that would look like -1 to the n plus 1 is n plus 2. X minus 5 to the n plus 1 over n plus 1 times 2 to the n plus 1. And then remember, you divide that by the current term, like by the nth term. But I don't want to spend two whole and, like, waste all that room on writing a fraction underneath. So let me do the keep change flip right off the bat. So keep change flip would put this on top and that on the bottom. So just flip the fraction, obviously. Like that. Okay, if you don't remember the ratio test, flip back a couple pages in your notes and you'll see that we were doing exactly this, like, 2 lessons ago.
Did you just get rid of the -1 to the n?
Oh. Okay. For this first example, yeah, you're right that I should. But I didn't even consider it. Good job. Maybe -1 to the n plus 1 down here. Sorry. I kind of did that subconsciously because because the absolute value, whether this is negative or positive, is not going to matter at all. So eventually, I'll just start ignoring the negative one. But for this first example, I'll just do it by the book. Okay, so now let's simplify this. Let's check everything that can simplify. The negative 1 to the n plus 2 can cancel n plus 1 of those and just be left with negative 1 here to the first. Then the x plus 5, or the x minus 5s, most of those cancel except you're left with 1 on top. The n's, this is another case where you feel like something should cancel here with n and n plus 1, but they just don't. So both of those gotta stay. I shouldn't have crossed them out, but I'm just saying, like, I've dealt with these now. And then the 2 to the n's, all of them will cancel except the 2 on the bottom. So I'm out of colors. Orange, these cancel these, and I'm left with 2 down here. Okay. Then, remember, where we're headed is that the ratio test says that if this limit is less than 1, then the series will converge. That's where we're headed. So keep that in your brain for a second from now. Now, let me tell you one thing. I'm taking the absolute value of negative 1 times some stuff. That absolute value, whether this is positive or negative, like, it's not going to affect the value of the thing. So this negative 1, basically, I'm just going to ignore, which is what I was saying earlier. This negative 1 to the any power is not going to make a difference on this. So eventually, you'll get used to, like, not even paying attention to that. So let me write this again without the negative 1, just for making it cleaner. This would be x minus 5 times n over, and then let me put the 2 out here, n plus 1. In fact, let me just distribute that too, also. Sorry. We'll distribute that too. You get 2n plus 2. Cool. Okay. Then, like I said, you're wondering when will this limit be less than 1, because that's when this is going to converge, right? So you just have to solve the equation that tells you when will this limit be less than 1. So first, let me figure out, do you guys know, just by looking at this, what the limit of it would be? Yeah, I would be surprised, because it's so abstract, because there's the x minus 5 and there's the n. But remember, the x is like, you're kind of thinking of that as I already plugged in a number, and now I'm checking what n is doing. So like, it's the n that's changing. The x is staying put for in terms of this limit. Like, the variable of the limit is n. So is that enough of a... Oh. Not 1/2, but yeah, you're saying the right thing, because this is n to the first, this is n to the first, so it'll be a ratio of the coefficients. So not 1/2, but x minus 5 halves. Nice, y'all. Okay, so the value of this limit is absolute value of x minus 5 halves. And like I said, if this is less than 1, then the thing will converge. So let me find out, when is this less than 1? Cool. And now the hard part is kind of done. Now it's just like algebra 1, like, can you solve this inequality? So, okay, you might not remember this, but if the absolute value of something is less than 1, then that means that that something is either goes up to 1 or down to negative 1. If you don't remember that, I'll let you try to convince yourself of that on your own. But yeah, if something is less than 1, that means, or the absolute value of something is less than 1, it means it could go up to 1 or down to negative 1. So that would mean that x minus 5 over 2 is between 1 and negative 1. Cool, and then now for real, this is just solving. So let me multiply by 2 on both sides and add 5, and then I'm done. So here's me multiplying by 2. Here's me adding 5. And then there's my interval of convergence. Okay, so what just happened? I just told. Remember when I plugged in 6 to like give you an intuition on what was going to happen, and it happened to be that when I plugged in 6 for x, the series converged. What this tells me is that if I had plugged in anything between 3 and 7, then the series would have converged. You smiling? You learning? Okay, very cool. Now let me tell you that we're unfortunately we're not done, but we're basically done. So we can answer one of the two questions. It says find the radius and the interval of convergence. The radius of convergence, we can tell it right now, because let me check how much intuition you have for this. You look at this function. If I asked you what's the center of, like, where's this function, where's this power series centered? What?
5.
Okay, all right, good. Yeah, it's this x minus 5. That tells you that's the center of the thing. Okay, and then the radius of convergence is asking you how far can you stray from 5 and still converge.
2.
Yeah, exactly. Because you can go up to 7 and down to 3. That's a distance of 2. And it should, oh, yikes. Let me try that. Well, that's a distance of 2 that I can go that way, or let's see if this one's better. Oh, there we go. 2 up or 2 down, and you can and you can still converge. And that distance will always be, just like by the nature of how absolute values work, that distance will always be the same on the right and on the left. So we can say that the radius of convergence is 2, big R equals 2. Cool. So that question is done. And then you're saying, wait, didn't you just tell us that this is the interval of convergence? Yes, but not really, because we just found out when this limit is less than 1. But you may or may not remember that the ratio test works as long as the limit is less than 1. But if it had been exactly equal to 1, then the series could have converged or could have diverged. So what I'm saying is at these endpoints, 3 and 7, the ratio test would have been inconclusive, and therefore we would have had to use a different test. So again, all of that is to say you have to check the endpoints. Plug in 7 and plug in 3 and see if the resulting series converge or diverge. So I know you don't have that much space left. But see if somewhere you can squeeze the fact that you have to check endpoints. X equals 3 and x equals 7. And then you'll be done. So what was I gotta see where this series was originally? But I'll show all my work just so you like see what I'm doing. But you guys can feel free to skip this first step or not, because you may have to be short on room. But basically, if x is 3, then this series turns into n equals 1 to infinity. It was negative 1 to the n plus 1, and then x minus 5 would be 3 minus 5 to the n plus 1, or to the n over n, like that. Okay, then this simplified would turn into the series from 1 to infinity, negative 1 to the n plus 1, times negative 2 to the n over n to times 2n, or 2 to the n, I meant. And then at any point on this, if you see, oh, this is going to converge or diverge, then feel free to stop. But me, if I look at this, I don't know if this is going to converge or diverge. So I would have to simplify one more step. So bear with me when I try to convince you that negative 2 to the n, again, you don't have to write this. I know you're short on room. But negative 2 to the n, I hope you agree, is negative 1 times 2 to the n, of course, which is also the same thing as negative 1 to the n times 2 to the n. Okay, so that'll help in a second, because this negative 1 and this negative 1 will combine, and good things will happen. So let me write that as the series, blah, 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 blah. negative 1 to the n plus 1 times negative 1 to the n times 2 to the n over n times 2 to the n. And this is what will always happen, is at the end points, after all of that work, you should get some nice things that happen, like, for example, this 2 to the n cancels that 2 to the n. And now you're smiling. And like I said, negative 1 to a power times negative 1 to a different power, you can just combine those. You know what I'm saying? So like if I just add these exponents, those can combine. So I'm going to need even more room. Sorry, x equals 7. I'll need another guy here that says the series from n equals 1 to infinity of negative 1 to the, here's me adding the powers, n plus 1 plus n.
2n plus 1.
Yeah, right? 2n plus 1. Yes, n plus n is the 2n plus 1. Okay, cool. And then if you're 32 years old like me and have a lot of experience in math, then you see this right away and you're like, this will diverge. But you guys seeing this for the first time, I don't know if you would have said that. But the thing is, like, do you see anything funky about this 2n plus 1? Yeah, okay, that's something that I see right away, and I'm like, oh, those are all odd numbers. Like this is the definition of an odd number, is plug in any number. Plug in 1, you get 3. Plug in 2, you get 5. Plug in 3, you get 7, etc., 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 etc. So what I'm saying is this is negative 1 to the odd every time, every time, every time, every time. So this is the series. Sorry. That's really the series negative 1 over n, which, sorry again, but that's the same thing as negative series of 1 over n. And then only finally do you maybe see this and say, oh, I know right away that this diverges, because this is the harmonic series. Okay, so all of that to say, nice job. We checked x equals 3, and it did not converge, so we had it right to start with. It is not less than or equal to, it's strictly less than. Sorry, there you go. X equals 3, not one of the points. Now we get to check x equals 7 in the same way. But I think that one is a little bit faster. So just to conclude the thought, x equals 3 gave me diverge. And now we get to check x equals 7 in the same way, but I'll do that faster now that you know all the tricks. So let me see if this will move my... Oh, it did it. Nice. Okay, so x equals 7, let's do it in green, would turn my series into n equals 1 to infinity, negative 1 to the n plus 1. 7 minus 5 is 2 to the n over n times 2 to the n. And now you've seen the tricks where this cancels that. There's no fancy negative 1 to combine with this negative 1, so I'm left with this series. Okay, and then if you look at that, half of you are going to get it wrong because you haven't practiced this enough. Like, you'll practice this over the coming weeks. But if you just look at that, you should be able to say if it converges or diverges. So think in your brain what you think it does. Okay, if you said, wait, isn't it just a harmonic series again? Then no, you're wrong, because this one at least alternates. This one does alternate. It's not always negative. So alternating series have a better chance of converging, remember? And all that needs to happen is that this limit needs to go to 0, basically. And since 1 over n does go to 0 by the alternating series test, this dude converges. Is that what you said in your brain? Good job. So then this guy actually converges when I plug in 7. And now we're finally done with the problem. That tells me that my interval of convergence is strictly greater than 3, but less than or equal to 7, since 7 is included in the numbers that I can plug in. Okay, so you can see I wasn't kidding when I said that first one is super dense and there's so much. You have to like keep track of the entire unit in that one problem, basically. But if you want a summary, I did the ratio test, I solved an equation, and then I checked the endpoints. Like in your brain, it's easy to keep track. Like do the ratio test, check the endpoints, and solve the equation. It's like 3 steps, basically. Question.
Because it's like the absolute value. Is it safe to just remember like it's between -1 and 1 and always set it like that inequality?
What?
Like that it's between -1 and you always just set it
from here to here?
Yeah,
that's always what you do. Yeah. I didn't know if you said like just look at the series and then you can automatically. I bet some people can do that, but I got to do all of it. Okay, so what time is it? 33. Okay. I do want to get this done. I do not want to keep learning into late next week. But the next two are pretty easy, like not as intense. So let me maybe put that on a separate page so I have space. Okay, and the next ones aren't as bad. So watch this. What x's can I plug into here so that this converges? Again, I can just check using the ratio test. So I set it up the same way as last time. I know your brain is fried, but like I said, these two more are not that hard. The ratio test, don't forget that it says plug in n plus 1 and then divide by the n term. So that would be x to the 2 n plus 1 plus 1. If you worked ahead, make sure you didn't just say n plus 2 here. The next term would be n plus 1 plus 1. So that would be 2n plus 3 if you're trying to skip steps. Over 2, not n, but n plus 1 plus 1 factorial.
It's your example. Wait, why is it like 2? Why is it not 2n plus 1 plus 1? Like, why is n plus 1 in
It's basically
parentheses?
if the nth term is 2n plus 1, then the n plus first term is going to be 2n plus 1, just like by definition.
Yeah.
Or more intuitively, these are all the, you know how I just said these are all the odd numbers, so then the next odd number would be 2 away, not 1 away.
Mm-hmm.
Okay, there's the n plus first term, and then the nth term, remember, I'm just going to flip this and multiply it. Keep change flip easy, so that would be -1 to the n, x to the 2n plus 1, and then 2n plus, no, okay, 2n plus 1 factorial up here. Okay. Like I said, I don't want to run out of time, so let me go through this one fast, but it's not as intense. -1 and -1 will cancel and just leave a -1 on top, but let me do two things at once and say, remember, the absolute values are just going to cancel the -1 anyway. So I'm ignoring the -1s, like, period. Then, okay, I guess a step in between, sorry, is that if you distribute this 2n plus 1, and then you add the 1, that's just going to end up being
2n plus 3.
Yeah, good job. X to the 2n plus 3. So let me do that right now and change this at 2n plus 1 plus 1 down here also to a 2n plus 3. Just to save ourselves some time. Okay, so now if I combine the x to the 2n plus 3 with the x to the 2n plus 1, I should have done that in red, sorry. Boom, boom. What are you left with? Let me
X
check.
squared.
Yay, good job with the squared, because this is 2 bigger than this, not just x, but x squared. Okay, so I'm here, limit is n goes to infinity. Oh, the absolute value of x squared is what I'm left with. And then the factorials are tricky. The factorials are tricky. Let me ask if you see it right away, and if not, I'll show you. Do you know how these factorials will cancel? Okay. All right, so then let me just show you with like a concrete number. Let's say I plugged in 1 in for n, then this would be 3 factorial over 5 factorial. I'll let you convince yourself of that. That would be 3 times 2 times 1 over 5 times 4 times 3 times 2 times 1. And if I plugged in a different number, same thing would happen, where these guys would all cancel except the biggest 2 terms, since this is 2 bigger than this. You know what I'm saying? Okay, so, and then the abstract notation, 2 terms of this would be, what I do, green. 2 terms of that would be, the biggest term is 2n plus 3, the next biggest term is 2n plus 2. Okay, convinced, you good? And then this is why I was saying this one is easy, because watch this limit that you got now. Remember, don't get thrown off by the x. Like, plug in a number for x if it helps you, because that x is staying static in terms of this limit. You're seeing what's going to happen to static over 2n plus 3 over 2n plus 2. So what is this limit going to be?
Converge.
What is it?
Doesn't converge.
Yeah.
Like it's just 1 over numbers.
Yeah, exactly. This is just number over huge number. Like as n goes to infinity, the x is staying put and the n's are getting huge. So this is 1 over huge number. So this limit is equal to 0. Cool, nice, I'm smiling because that's always less than 1. Which tells you what? Let me check on you. What's that tell you about this sum? Yeah, maybe it doesn't tell you that much right now, like your second problem ever seeing this. But that tells you that no matter what I plugged in for x, this limit is always going to be less than 1. Meaning I can plug in anything, any x into this series, and it will still converge. Yeah. So the interval of convergence is like all real numbers. And therefore, something I think I skipped on the last page is that means that the radius of convergence is infinity. Cool. And then the next one we can do in the 5 minutes, and even the well, maybe we'll save that one for tomorrow. I guess like with that one multiple choice question that I said save it for last week. We'll do that tomorrow. Really quick question. Oh, this canceled all but 2 terms of this. So this used to be like a ton of numbers. Now it's just 2 factors because of what happened here. 3 times 2 times 1 over 5 times 4 times 3 times 2 times 1. All of these will cancel all of these except for 2 biggest terms. Like because this is too big. This is too bigger than that. Cool! Good question. Alright, and then this last one, again, is not very hard. It's the quickest one, I think. But again, you're wondering what x's can I plug into here so that this converges? Actually, maybe you have to do 0 work. But like, look at that for a second. What x's do you think you can plug into that so that that converges? Or maybe you might not have the intuition. Okay, but if I see, this is why I'm saying like this is kind of a silly problem, is because this is n factorial, not 1 over n factorial, but n factorial times another number to the n power.
It's going to get huge.
Yeah, this is just going to get very, 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 very huge. Like this isn't even, like even if this is a tiny decimal, the n factorial will outgrow it. So there's nothing you can, well, except other than 3, there's nothing you can plug in. But how would you know that? Well, just do the same thing as last time, where you set up limit as n goes to infinity. You set up a ratio test, n plus 1 factorial times x minus 3 to the n plus 1. In this one, luckily there's no fraction, so there's no keep, change, flip. You just straight up whoop, divide by the nth term. Yeah, that's it. That, and then you cancel everything you can. Again, I'm gonna go fast because we're out of here in 3 minutes. So, obviously the x minus 3's, all but one of these will cancel, so I'm left with x plus 3 on the top. I'm sorry, x minus 3 on the top. And then for the n factorials, do you guys remember how those cancel?
N plus 1.
Yeah, you're just, this is 1 bigger than this, so the biggest term is going to be left over where all the other factors will cancel. So actually, I wrote the wrong thing here because it's not even going to be a fraction. It's going to be x minus 3 times n plus 1. And again, it's hard seeing it like this, but remember the x is static. Remember, you're thinking of it like I already plugged a number into this, and now I'm checking what does this limit do. So what happens to this expression as n goes to infinity?
That's huge.
Yeah, it gets enormous. Like there's not even any slowing down. Like there's no fraction to even slow it down. This just gets bigger and bigger and bigger and bigger the bigger numbers you plug in, the bigger n's you plug into this. So that limit is infinity. That's all. There's no number I can plug in that makes that smaller than 1, except if x is 3, then this is 0 plus 0 plus 0 plus 0 plus 0. So therefore, this only converges when x is 3. Meaning the radius of convergence is 0. Okay, but most of the lesson happened on that first example, like I said. Cool, okay, then we could do... Nah, let's save this one for last, because we're going to have 2 days for 10.8 anyways. We could do this one tomorrow, but don't forget, that's a good question. So 10.8 tomorrow, 10.8 Monday probably, then we'll be all done curriculum, and then just review time. And we could even freaking come in on Wednesday, because I won't have a meeting that Wednesday. Cool, you guys, good job.